In this video, we're going to work on examples 8.5 to 8.11 from your book. If you'd like to follow along, open the Chapter 8 Classwork.xlsx workbook from My Courses and click on the EX 8.5 worksheet tab. In this example, we're going to use Excel functions to do a regression. We're going to use market value as the y, or the dependent variable, and we're going to use square feet as the x, or independent variable, and we're not going to use column A, house age, at all. So the first thing that we're going to do is we're going to calculate the slope, or the variable portion of the regression. So we're going to click in cell F1. We're going to click the Formulas tab. In the Function Library group, we're going to click More Functions, Statistical, and then scroll down until you see Slope. In the Known Y's, we're going to select the range C4 down to C45. We're going to scroll up, click in the Known X's, and select the range B4 to B45. Then we click OK, and notice we get the answer 35.03. Now we're going to use an Excel function to calculate the intercept. We're going to click cell F2. You should still be on that Formulas tab. In that Function Library group, click More Functions, then Statistical, and this time scroll down until you see Intercept. It asks for the same thing, the known y's and the known x's, so we're going to do exactly the same thing. Our known y's, the range C4 to C45, then click in the known x's, scroll up, B4 to B45. We get an intercept of 32,673.22. We click OK. And what this regression tells us is that if we know the square feet, we take the square feet, multiply that by 35.03, add that result to 32,673, and we have an estimate of the market value of that house given these data. Now we need to know how good a relationship this is, so we're going to calculate the R-squared value for this regression. So we're going to click cell F3. Once again, Formulas tab, Function Library group, More Functions, Statistical, and this time we're going to look for RSQ. R squared is a number that runs between 0 and 1. If you get an R squared value of 0, that means that basically you've just wasted your time. It's a terrible regression. It's not going to predict anything. If you get an R squared value of 1, that means that the regression perfectly predicts all of the market values. So the closer you get to 1, the better you are. So for our R squared value, it's going to want the known y's, C4 to C45. Known x's, click in the box, scroll up, B4 to B45, and click OK. We get an R squared value of 0.53, very mediocre. It basically means that a little over 53% of the variation in market value is explained by the variation in square feet. So not a great regression. So as I told you, if you are given a house of 1,750 square feet and you wanted to predict the market value using our regression results, you take 1,750, multiply it by 35, and then add that result to the 32,673. You can have Excel do that for you with the trend function. So we're going to click in cell F6. We should still be on that Formulas tab. Function Library Group, More Functions, Statistical, and scroll down until you see Trend. So first it's going to ask for the known y's, C4 to C45, known x's, B4, so click in the box, scroll up, and select the range B4 to B45. Now we're going to click in the new x's box and scroll up. We could just type the 1750, but then we'd have to bring up the formula to change that. So in the new x's box, we're going to click cell E6. Notice the result says 1750, but now we can type any number into cell E6 and have that estimate of the market value come up in cell F6. Now the next box is CONST, which we're going to leave blank. Leaving it blank allows us to have an intercept. If we put in false, it will force an intercept of 0, which is not what we want. So we're just going to leave the CONST box blank and click OK. And notice we get an estimate of the market value of 93,986.87. Let's check that number. I told you the regression results mean that, so I'm going to click in cell G6. I'm going to type an equal sign. If I take the 1750, so I'm going to click on E6, multiply that with an asterisk by F1. So take the new x value, multiply it by the slope, and then add the intercept. Notice I get exactly the same number, 93,986.87, and again I can change that to any number. And have it recalculate automatically. Now we're going to use a new function, linEst, linear estimate, to also calculate the slope and the intercept. LinEst is actually an array function, which means its output spills into more than one cell. So we have to do something special with an array function. So first, to start off, we're going to select the range E10 to F10, because that's where we want the output to be in the two cells for the slope and the intercept. We're still at the Formulas tab, Function Library Group, More Functions, Statistical, and this time linEst. It's going to ask for our y's. We've done this before, C4 down to C45. Scroll up. It asks for our x's, B4 to B45. And asks if we want to set the constant to 0. We do not want that to happen, so we're going to leave that blank. And then we have stats. If we type in true, we'd actually get more than 2 cells as the result. We're going to leave it blank to not get the additional statistics, to just get the slope and the intercept. But now what's going to happen is we can't click OK because we'd only get the 35 slope. In order to get the formula to fill over into both the cells, we have to hold down the Control key, then Shift, so Control Shift and then Enter. And notice now we get the same slope and intercept, 35.036 and 32,673.22. Now we're going to work on examples 8.6 to 8.11. So click the EX 8.6 to 8.11 worksheet tab. We're going to click the Data tab. You should see an Analyze group on the right-hand side with Data Analysis, and/or solver. If you do not see the Analyze group or you don't see Data Analysis, click File and then Options. On the left-hand side, click Add-ins. Next to Manage Excel Add-ins, click Go. And make sure the Analysis Tool Pack is checked. Solver is not important. We will use it at a future date, but not in this chapter. So make sure that Analysis Tool Pack is checked and click OK. And when you go back to that Data tab, you should see an Analyze group with the Data Analysis tool. So we're going to click Data Analysis, and we're going to scroll down until we see Regression. We're going to single click Regression and then click OK. In the Input Y range, we're now going to select the range from C3 instead of C4. Then we'll get our labels in the output. So in the Input Y range, we're going to click the range C3 down to C45. We're going to click in the Input X range box and scroll up. We have to select the same number of rows. Very important that they both have the labels. So we're going to select B3 down to B45 and make sure to click that labels box. Now I'm going to click Output Range, and I'm going to click in the box next to Output Range, which allows me to scroll back up. In the Output Range, I'm going to click cell E3. So my output is going to be in this area right here. And I'm going to make sure to check residual plots. We're going to use that in one of the exercises. So we're now going to click OK. We have all of our regression output. I'm going to double click the column borders. So I'm going to double click between E and F and G and H and I and J and K and L and M and N. So we can now see our summary output. We have our R squared and our adjusted R squared, which we've already calculated. We have our standard error and our number of observations. Here we have the ANOVA, which is the analysis of variance, and we're only going to look at a few of the numbers. In example 8.6, we look at the R squared value. So we've taken a look at that R squared value, 0.534. In example 8.7, we're going to look at the significance F for the regression. So we take a look at the significance F. That is actually the probability that the regression is totally bad. We can see that it's e to the negative 0.08, so it's not 3.79, but it's 0.000000003.798. So our significance F is a very low number. So we can see we have good confidence that our regression is good. If this number was 0.05 or above, we would probably just throw out this regression. Now we're going to look at the p-values for our coefficients. That is going to be example 8.8. We see once again two very low p-values. If we had seen 0.05 or above, there would be a good chance that either one of these numbers is actually 0 and not a number. So we've got very low p-values, so we're not only confident in the regression, but also somewhat confident that our coefficients are not 0. Now we're going to take a look at the confidence interval. So our best guess for that intercept is 32,673, but with 95% confidence, we know it's between 14,823 and 50,523. Square feet, our best guess that the coefficient is 35.03. There's a 95% chance that the true value is somewhere between 24.6 and 45.5. Now, the last thing in examples 8.10 and 8.11, we check the residual output and check the regression assumptions. This is not a statistics class. You can read about the regression assumptions. Here is our residual plot, and you can just read in the book, but basically for this to be a good regression, we should have them evenly distributed both above and below the line, and this point up here is most probably an outlier. We should probably take it out of our data set and rerun the regression. Alright, we have now worked on examples 8.5 to 8.11 from your book.